So, welcome to this review video for our final exam in mathematical logic. I'll be talking a bit about some of the learning objectives, some of the pitfalls that we've had throughout our various modules in the midterm exam, and then I'll be saying a bit about the logistics of the final exam, for example, what its format will look like and how you will complete it, when the due dates are, and what the timeframes sort of look like. So here's a bit about the format of the exam. The final exam will be in two parts, just like our midterm exam. In part one, you'll be able to use your notes, Fitch, Boole, and Tarski's World, and you'll have the full week to work on those questions. They'll be a bit more detailed and can take some time to figure out some of the details. You won't be able to consult the textbook, the internet, or any other sort of classmates or tutors on that part of the exam. But your notes, Fitch, Boole, and Tarski's World are all fair game. On the second part of the exam, it will be a timed 1 hour exam on Blackboard. You won't be able to use any notes, Fitch, Boole, or Tarski's World. The exam will be similar to what you saw in the midterm. There will be no backtracking. It is 1 hour timed. It's one exercise at a time. And it is going to be basically 10 questions. A lot of them are going to be related more to sort of vocabulary sort of stuff and identifying certain things from a list, right? So I may give you a list of expressions, and you should identify if it's a well-formed formula or if it's got a free variable and things like this. And as I talk about the learning objectives on the next couple of slides, I'll say a bit more about what some of those questions can look like on part two. Now, those two exams are worth the same number of points, and together they'll add up to 100 points, which will be your score on the final exam. The final exam itself will appear on December 3rd. That's Monday in the morning, and you'll have until Friday at midnight, December 8th, to finish up both parts of the exam. Part two of the exam, you should make sure that you have a 1 hour window that you're ready to work on that part of the exam, because as soon as you start it, you'll get just basically one chance to work on it, and you won't be able to sort of backtrack on that particular part of the exam. And then part one, you'll sort of write up via handwritten notes and scan them the way that you would notes on the midterm, or maybe notes for a class assignment or a module assignment. If those dates don't work for you, I realize that this final exam is directly during sort of the work week, Monday through Friday. If those times don't work with you, you can send me an email, and I'm more than happy to try to work with you on a different sort of time frame for completing the exam. But please just reach out, and we can try to figure something out. And then before I go on to those objectives, let me just point out two things that can help you improve your course grade. First, I will be dropping your lowest module grade from the module average. And what that means is that if you had a 0 on one of your module grades, it won't impact your score. And I'll do that as soon as I have all of the modules completely graded, which my goal is to be done before I give out the final exam on Monday. Now, the other way that you can improve your course grade is you can submit up to 2 assignments that you missed during the semester, or that you maybe didn't fully complete. And again, that'll be due at the same time as the final exam on Friday at 11:59 p.m. There won't be any sort of late penalty on those particular assignments. And it's not the entire module, but just the assignments. So you could pick 2 homework assignments, a note assignment, and a homework assignment, maybe 2 discussion board assignments or something like this. But any 2 assignments that you may have potentially missed, you can go back and complete. And you can use the same links to submit everything on Blackboard. And if they are not working, or you find some issues, you can send that information via email letting me know which ones that you plan to work on. So these are the learning objectives for our final exam. First off, all of the objectives from the midterm exam are in play for the final exam. And what that means is that any of the questions that appeared on the midterm exam could, again, potentially appear on the final exam. On the other hand, the final exam will be a bit more focused on our newer learning objectives. In terms of questions that we missed on the midterm exam, one thing that you will want to go back and refresh yourself on is how you take a truth table and turn it into a formula in CNF, conjunctive normal form, or DNF, disjunctive normal form. And the algorithm is laid out in the textbook, but I lay out both of those algorithms in the lecture video in a bit more detail. That was a common mistake on our midterm exam, and so it would be a good idea to come back and make sure you understand how to construct that CNF or DNF formula directly from the truth table. The other sort of common error on the midterm exam was a confusion between atomic sentences and terms. Remember, terms are created by iteratively applying function symbols to constants, and terms name objects in the domain of discourse. Whereas atomic sentences are applying predicates to terms, and they represent sort of statements about objects in the domain of discourse. Okay, so it again would be a good idea for you to review your midterm exam and just go back over the video and look over some of those learning objectives from the first exam. Now, the new material from after the midterm exam included information about variables and quantifiers. So the first thing we did was construct well-formed formulas, or what we were calling WIFs, and you should be able to recognize and construct well-formed formulas on your own in any given first-order language. So there may be a language that we specify on the exam that we haven't seen yet, not the blocks language or set theory or arithmetic, but maybe some new language. And you should be able to recognize and construct well-formed formulas in that particular language. Now, you should also, once you construct those well-formed formulas, be able to determine if a variable in your well-formed formula is either free or bounded. And this is a particularly important one, especially on the part of the exam that will be timed, because I will hand you a collection of well-formed formulas and ask you to identify those that have a free variable and those that have no free variables. And I mentioned this because on the discussion board for module number 11, we had to do a similar sort of thing in the language of set theory when we were applying it to the separation axiom. And there was lots of confusion about basically writing down a well-formed formula with a single free variable. Now, part of the issue with that discussion was that in set theory, there are no constants at all. And so even A, B, C, and D are considered variables. So I think that might have confused some students, whereas we would normally sort of call them constants in the blocks language or in perhaps another language as well. But again, it'd be a good idea to go back and just read up on that section about well-formed formulas and free variables and bound ones, because I'll be asking you to pick them out of a lineup. A similar sort of thing here is for atomic well-formed formulas and sentences. Remember, a sentence is basically just a well-formed formula that has meaning, and it has meaning because there are no free variables in that particular sentence. And then the atomic well-formed formulas are the ones that we built up sort of at the very base. So again, it'd be a good idea to go back and just review that definition. Now, once we built up our well-formed formulas and we constructed our sentences, we talked a bit about how we can determine if a quantified sentence is either true or false based on the meaning of our quantifiers, the universal quantifier and the existential quantifier. And you should be prepared to do that sort of thing if I, for example, give you a Tarski's World file with some shapes in it with blocks or things like this, you should be able to then determine if a given sentence, a quantified sentence, is either true or false. And you will have to also do that if you look at, for example, something like number 10 for multiple quantifiers, right? That one says translating in English, but be prepared to sort of analyze sentences that have more than one quantifier. Okay, so that was objective 6. Now, another really important component of the exam, and something that we did sort of poorly on, I believe it was module 10, was constructing the truth functional form. And that's just because from time to time it's easy to skip across a negation or put a negation in a different spot. But you should go back and review that exercise from module 10, where you had to construct a bunch of sentences in truth functional form, and just make sure you understand any of the mistakes that you might have made there, because I'll be asking you to do just that, right? Handing you some sentences with quantifiers and asking you to produce the truth functional form. Now, in addition to that, objective 8 is also asking you to determine if a given quantified sentence is actually a tautology. And the way that you would do that is you would take that sentence in its truth functional form and construct a truth table for it. If you got T's in that sort of main primary connective for that quantified sentence, then you would be dealing with a tautology. And if you didn't have T's there, you'd be dealing with something that's not a tautology. Likewise, for tautological consequence, you first would translate your entire argument to truth functional form, and then look at a joint truth table to determine if something is a tautological consequence. And remember, in Fitch, what that meant was that you could then apply the top-con procedure to justify a particular step. By the way, on the final exam, anytime that you're constructing a formal proof, I will allow for the use of top-con. And in fact, if you do use it, it can save you quite a bit of time and quite a bit of steps on certain arguments. Now, a really good way to know that you could apply top-con in an argument is that there perhaps are no quantifiers in your argument, or no quantifiers in the sentences that you're trying to cite. And if that's the case, then most likely, if it really is a consequence, a logical consequence, then you can get it with a tautological consequence. Okay, so you'll be or you should be prepared to analyze arguments and sentences in terms of their truth functional form. For number 10, you should be able to translate English sentences with multiple quantifiers into first order logic and vice versa. And remember, there's a lot of room for your own spin on things here. So as long as you write something that is reasonably close or reasonably logically equivalent to the original sentence, you should get full credit. Another area that some students struggled with on the homework assignment, I forget exactly which module it was part of, was the assignment on constructing premix form. Remember, when you're putting something in premix form, you're moving all of the quantifiers out to the front, and you're definitely changing the truth functional form of the sentence, but not its logical equivalent. So it'll still be logically equivalent to the original, but as you pull those quantifiers out to the front, you'll be putting it into that premix form. Now, just as a reminder, there's no real proof there when you're doing that. You're just sort of rewriting it in a different format. And there will certainly be a handful of questions where I ask you to go through that process and document the steps that you used to get there. And we talked about some of the basic logical equivalents that were needed to put something in premix form. So be prepared to put things in premix form, and then also to just identify if a given sentence actually is in premix form or not. So there may be on the timed portion of the test, a list of sentences, and you'll have to sort of identify those that are in premix form or potentially not in premix form. Okay, so the last one on this particular slide, we have one more slide with some learning objectives, is about using our sort of informal proof methods for quantified statements. And we had universal and existential elimination introduction. And then we had the special method of general conditional proof, which in Fitch goes by universal introduction. So it's done basically the same way. So there's sort of two formats for universal introduction in Fitch. Now, I would just say that this objective is good in the sense that it'll help you sort of move towards a formal proof. But I'll tell you right now that nowhere on the actual final exam will I ask you to construct an informal proof. But instead, I'll be asking you to analyze and potentially construct formal proofs. Again, these informal arguments and understanding how they work can help you build towards a formal proof. So here are the remaining learning objectives for the final exam. The first two here are just asking you to be able to construct formal proofs in Fitch using our introduction and elimination rules. I'll remind you that the universal introduction had two different forms, one of which was called the general conditional proof, and being aware of how to use both of those will be helpful on the final exam. Now, those two objectives can come up on both parts of the final exam. In the sort of timed version of the exam, you'll be asked to analyze proofs. So I'll provide you with an actual proof and ask you to determine if there's an incorrect step or something like this. And then for another instance, I might leave off the justifications and ask you to determine what the correct justifications actually are, similar to what we did on the midterm exam, but now we have some extra rules. And then on the sort of take home version of the exam, you'll be doing mainly what is there at the bottom of these learning objectives. That's determining if an argument is valid or invalid, and when it's valid, constructing one of these formal proofs. Now, our third sort of objective on this page here is to apply the axiomatic method. And here that'll be for something like ZF, PA, or one of our shape axioms. Now, I won't make you memorize any of these axioms, but you may have to contend with some arguments where some of the premises are some of these statements from either set theory, its axioms, or Peano arithmetic, or potentially also the shape axioms. In terms of set theory, there are sort of three main things that I'll ask you to be able to do. First is to apply some of our basic set operations. So if I hand you a collection of sets, say A, B, and C, you should be able to form the power set of one of those sets, the union of those sets, the intersection of those sets. You should be able to apply the axiom of separation along with a well-formed formula of the single free variable in order to construct a subset. And list out essentially what those elements are. And I may ask you to do that mainly in the timed version of the exam because those are pretty straightforward sort of computations if you understand what those operations are. The other thing I'll ask you to do is to show that two sets are identical. And the way that you show two sets are identical is to argue or prove that their elements are the same. Related to that is the notion of a subset. And to show that a set A is a subset, for example, of a set B, you show that every element of A has to be an element of B. In other words, basically a general conditional proof. That's all I'll ask you to be able to do in terms of set theory. Now, in terms of first order structures, the completeness theorem and the incompleteness theorem, those topics, although we covered them in our last module, won't be appearing on the final exam. On the other hand, that last learning objective on this page will appear quite extensively throughout the exam. So I'll be handing you some sort of argument in a first order language and asking you to determine if it's valid or invalid. If it happens to be valid, you'll be asked to construct a formal proof using the Fitch system. And if it's invalid, I'll be asking you to construct some sort of counterexample to show that it is an invalid argument. And a lot of the questions from chapter 13 were along these lines, right? Where you were handed some sort of argument and then asked to do this sort of analysis. So those are all excellent um, examples of the types of questions that you might see on the final exam. Now, one last thing to mention here is that when you're doing that analysis and constructing those formal proofs, it's always going to be okay on this exam to use TOC-CON in any of your formal proofs. And that potentially could save you quite a few steps and quite a bit of time if you use it in the right way. Now, one way to sort of recognize that you can use it is, going back to truth functional form, or if you're in a part of a subproof or an actual proof where no quantifiers appear in any of the sentences that you're citing, it most likely will follow from an application of tautological consequence or of TOC-CON. Okay, so that is it for the learning objectives and some of the details for the final exam. I will be around next week and available for sort of visits via office hours if you have any questions about clarifying these objectives, or maybe answering or asking questions about some of the topics before you jump into the timed version of the exam. Um, but you could just send me an email and we could set up a time and talk for maybe an hour or so, or 30 minutes, to just clarify anything that might be missing.